Hello, all you IM10 students. This is a video for the Proofs Day 2 in-class notes. I'm sorry I'm not here to help you. Feel free to pause the video if you need to write down notes or kind of go over things in your mind, digest what I just did. So pause the video as much as you need to. I'm going to continue going through each proof just to make the video a little bit shorter. So let's go ahead and start with the in-class Proofs Day 2. And please fill this out on your note guide as we go along. So for number 1, you're given that T is the midpoint of A to H, and A is the midpoint of M to T. So before you even move forward, I would mark that, what you can mark on your diagram. So knowing that T is the midpoint of A to H, you can conclude that AT and TH are congruent. A is the midpoint of M to T. So you can also conclude that MA is congruent to AT. Let's go ahead and fill in our T-chart. So step number 1, list all of your givens. So you are given that T is the midpoint of A to H. And you're also given that A is the midpoint of M to T. And the reason we know this information is because it's given. Okay, we are trying to eventually prove that MA is the same as T to H, that they are equal. So what we can do with a conclusion of the midpoint is that we can say A to T, and these are the segments that we marked in the diagram, is congruent to T to H. And we know those are congruent by the definition of midpoint. That's what midpoint means. Same thing with step number 4. We can conclude that segment MA is congruent to segment AT, also definition of midpoint. Well, if you take a look at lines 3 and 4, you can see that AT is congruent to TH, and AT is also congruent to M to A. So these pieces, I'm going to kind of put an arrow here, are matching. Okay, so you can substitute TH in for A to T because A to T is equal to that. So on line 5, you can conclude that segment MA is congruent to segment TH by substitution. You substituted line 3 into line 4. And your proof is now concluded because that's the proof statement. M to A is congruent to T to H. So you can go ahead and box that, being all done with your proof. Let's continue with number 2. O is between S and N is the midpoint of O to G. We can't really make any conclusions about O in between S and N because it doesn't say that O is the midpoint, but N is the midpoint of O to G. So you can conclude that ON is congruent to N to G, and N to G is 5. So I label this segment with 5. Okay, we need to prove that the entire segment SN is equal to SO plus 5. So somehow we need to prove that this is also 5 from O to N. And then we need to prove that this entire segment is the addition of the two small ones, knowing that O to N is 5. So let's kind of put all this together. First, list your 3 givens. Okay, so we need to end up, our proof has to use the segment addition postulate. You have to say segment SN is created by SO to ON. So we need to somehow make a formula. First of all, let's conclude that segment ON is congruent to segment NG. That's the definition of midpoint. That's how we knew those two segments were congruent. So this is definition of midpoint. Now we can substitute 5 in for n to g because that's what n to g is equal to. So line 5, we're going to say segment ON is equal to or congruent to 5. Okay, so this one we substituted information from line 3 into line 4, and that's how we created line 5. Now that we know O to N is 5, let's go back up and let's create an equation from S to N. So S to N is equal to, that entire segment is equal to the addition of the two smaller ones. SO plus, sorry, I need to remember here, ON. And this is called the segment addition postulate. You added two smaller segments together to create a bigger one. Last but not least, you know O to N is 5. We proved that above in line 5. So let's substitute 5 right here. So your final statement is S to N equals SO plus 5. And you substituted information from line 5 into line 6. And that's it. This last statement matches your proof statement. So you can go ahead and box that up. All done. Let's go to proof number 3. You are given that AB plus BC equals 10. So these are just some random segments. You're also given that XY plus CD, that same piece, is also 10. Okay, so they're equal to the same length. And you're trying to conclude that AB is congruent to XY. It's like if we got rid of C and D, those two things would be equal in the givens. So let's go ahead and list our givens. If both statements are equal to the same number, they're both 10, they're both equal, you can actually substitute this entire statement right here. They're both equal to the same thing, so set them equal to each other. So you have AB plus CD is now equal to XY plus CD. And all we did was we substituted information from line 2 into line 1. Well, we need, our proof statement does not have a C and a D in it, right? We just want to conclude that AB is congruent to XY. So why don't we subtract? Let's subtract CD here. And whatever you do on one side of your equation, you have to do to the other. It's all about balance. So let's go ahead and write our simplified statement. AB, this cancels, is now equal to XY. And the reason that we subtracted CD is called the subtraction property of equality. You're subtracting from one side, you have to make the other side just as equal. And that's it. You're all done. Go ahead and box that one up. Let's go to proof number 4. Proof number 4 is actually identical to proof number 3. So you know what? I'm going to let you guys go ahead and do that one by yourselves. Please do that one for homework. I do want you to follow along with number 2 on the homework assignment because this one is a little different. So please go to your homework assignment, proofs day 2 assignment, and follow along with number 2. So I'm giving you a freebie here. Let's go ahead and list our givens. We are given that angle A is a right angle. We are also given that B is a right angle. Well, we know that right angles are equal to 90 degrees. That's by definition. So let's go ahead and conclude that the measure of angle A is equal to 90 degrees. That's the definition of a right angle. That's what makes the right angle a right because it has 90 degrees. Same thing with angle B. This is also a right angle by the same reasoning. Definition of a right angle. Well, just like proof 3 and technically proof 4, A and B are equal to the same number. So let's go ahead and substitute this one here. Okay, and I sometimes tell my students the number that's repeating is the one that's going to disappear. So your 90s are both the same, they disappear. What you have left over is the measure of angle A is now congruent to the measure of angle B. And you're all done. All you did was substitute line 4 into line 3. And you have proved that those two angles are congruent. You're all done. Please finish this assignment and that proof on the homework or on the note guide number 4 and hand this in. And then when you are finished with this assignment, you can work on your Mathia. It is due November 9th, all the units. If you have any questions, please email me. Thank you.